graduate of private senior high school and currently doing a science project in National Taipei University of Technology. And my project today is modification of plant-based starch powders for anti-adhesion applications. So nowadays, tissues in our bodies tend to stick to each other after the surgery, which causes pain to the patients. So there has been membrane anti-adhesion materials nowadays to put into the body to prevent tissue from sticking together. However, due to the development of the minimally invasive surgeries, the holes in our body became very small, so the membrane materials are harder to put into the body easily. So therefore, there has been researches about powder forms of anti-adhesion materials that can be used to solve these problems. So in my research, I'll be focusing on two questions. The first one is, can the original plant-based starch be used as anti-adhesion materials? And the second one is, how can we improve its water absorption ability to form into an effective hydrogel? So in my methodology, we can see that first I chose 5 different kinds of plant-based starch, which is potato starch, tapioca starch, cornstarch, sweet potato starch, and also acetylated starch phosphate. And then by selecting the best starch with the highest water absorption rate, I modified it in the emulsification process with 3 different salts, which is sodium chloride, potassium chloride, and calcium chloride. And after modifying the starch, I took them to check their powder morphology analysis, FTIR, water absorption test, viscosity test, and lastly is the animal test. So let me introduce some brief introduction of the emulsification process. So basically in the emulsification process, I mix water phase and oil phase together. And in the water phase, it includes the acetylated discharge phosphate, which has the highest water absorption rate among the 5 different original plant-based starches. And in the water phase, it also includes DE water and also the 3 different additive salts. As for the oil phase, it includes surfactant and triglycerides. And by adding these two phases together, and then by mixing, stirring, centrifuging, participating, and lastly, we use them in the vacuum filtration and drying, and this is how we get our modified powders. So for the first results, it's about the different water absorption rate of 5 different starches. So as you can see, we found out that the acetylated discharge phosphate has the highest water absorption rate among the 5 different starches. And this is one of the reasons why we took them into the emulsification process to modify it. And as for the 3 different modified starches, we found that the starch modified by sodium chloride has the water absorption rate up to 1,300. And as for the potassium starch modified by potassium chloride, it's about 1,100, and for the calcium chloride, it's about 1,000. So it can be seen that the starch modified by sodium chloride has the highest water absorption rate. And later on, we took these 3 modified starches and added water into it so that it can form into a hydrogel. And one of the reasons why we want to test the viscosity of the hydrogel is that when the starch was put into our body, and by adding water into our body, it forms into hydrogel. And it becomes the bounce between the wounds in our body, and it prevents them from sticking together. So we want to make sure that it won't be sliding away from the wounds in our body, so we want to check the viscosity. And we can see that the sodium chloride, starch modified by sodium chloride, has also the highest hydrogel viscosity, which is up to 90.83. And for the morphology of starch powders, we can see that in the SEM images, the starch modified by sodium chloride has the smallest powder size. And as for the FDR analysis, we can see that the functional groups of OH and CO between the raw starch, which is the acetylated discharge phosphate, not modified yet. And the 3 different modified starches can be seen different. And we also did some animal tests to make sure it's useful and beneficial to mice. So the basic steps in the animal test is, first we put the mice under the anesthesia, and then the abdomen of the mice was cut open. And we also brought their intestines until they bleed, as you can see in the first picture. And then after they bleed, we put the 3 3 different modified starches onto their wands. And as you can see in this picture, and after we spread the starches, we let them undisturbed for 2 weeks, and then we can see the result. And here's the result of the animal test. So we can see in this chart that the starch modified by sodium chloride has the least adhesive tissue thickness to the mice. So it also means that it has the best anti-adhesion effect. So therefore, we can see that when the starch has a higher water absorption rate, it means that it has a better anti-adhesion effect. And second to the last is my discussion. So I separated the discussion into 2 parts. The first part is I wanted to discuss about the mechanisms of high water absorption of the acetylated discharge phosphate. So because the acetylated discharge phosphate was gelatinized from potato starch, and in the gelatinization process, the potato starch was heated in acetic acid, so it prompts the part of the micelles of the starch to form voids, and it further allows more water molecules to enter the interior, so which improves its water absorption ability. As for the effects in the emulsification process and different salts on water absorption, because in the emulsification process, the salts were added onto the starch, which first enlarges the total surface area, and second, we guess that maybe it could enlarge the positive charges to attract more water molecules. And throughout the emulsification process, the size of the starch decreases. So in comparison, under the same grain weight, when there are more starch particles, it means that the total surface becomes bigger. And then with the bigger total surface, it means that it can absorb more water and forms it into bigger hydrogel. And last is my conclusions. There are 3 conclusions in my whole research. The first one is I knew that through the emulsification process, by adding salts onto my starch, it can improve its water absorption ability and then turns into the hydrogel with a high viscosity, which is beneficial to my anti-adhesion materials. And the second is among the 3 different modified starches, I found out that the starch modified by sodium chloride has the smallest powder size and also has the highest water absorption rate. And lastly, I knew that the mechanism of the emulsification process and water absorption of different modified starches were proposed and built. Last, for my future development. So, of course, more variables should be investigated more, such as the different concentrations of the solutions and more modified starches, so that we can detect more effects on anti-adhesion properties. And also, biocompatibility, cytotoxicity, and more animal tests should be conducted to improve the safety of my anti-adhesion materials. And this is my animal speech. Thank you so much.